All right, give everybody another minute or so to jump in. So as an announcement, please remember to do your normal sign-in deal with the chat, but also this Friday is Good Friday, and it is a school holiday, so we will not be meeting for class on Friday. All right. Okay. So we've been going over some percentages and some different ways to kind of talk about large data sets with smaller numbers that depend on that data set. First, we talked about the mean, median, and mode, which are different versions of the, I guess, average number in that data set. I did say that each of those numbers kind of gets used interchangeably as the average, depending on what people either feel best represents that data, or depending on if there's anything, if one of those, or if that person has may have an agenda, then they'll pick the one that lines up with their agenda the most to say is the average. But either way, this had to do with the average amount of or value of that data set. We've since been talking about quartiles or percentiles, and this has to do with looking at specific numbers in a data set to see what this tells us about either the data or about that specific number in the overall data. So quartiles was just dividing the data set up into 4 different sections, and we had 3 quartiles where Q1 was bigger than the lowest fourth of the data, Q2 was bigger than the lowest half of the data, and Q3 was bigger than the lowest 3/4 of the data. And then the 4th quartile, someone had the best possible answer, which is it's just the largest number. But even that isn't exactly right with how we defined quartile, which is why we don't have a 4th quartile, because it would be the number that's bigger than all of the data. But that number is not in the data, so it doesn't exist. We started talking about percentiles, which is dividing the data up into percents, or 100 pieces rather than 4, and talking about which percent of the data is in question. So the little the equation that we got for calculating a percentile is this one. B equals N times P over 100, or if you're looking for the percentile, P equals 100 over N times B. So B is the number of items below some P percentile, and N is the number of items in the data set altogether. We kind of started with this example. So we did part A, what is the value of the 10th percentile? And for that, we said, take this equation, B equals N times P. We said that there are 25 items in the data set. In the 10th percentile, what is happening?
25 is the total amount of numbers, right?
Yeah.
All right. Keep talking about with that noise. Somebody alarm going off.
All right. Yeah, so 25 is the total number of numbers in the set. And P, the percentile, we want to know about the 10th percentile. So if you do this out, you get 2.5. And when we're doing this, the way they say to round it is B is technically the number of numbers below the number we're looking for. So you're supposed to round it down. So in this case, there are 2 below the number we're looking for, meaning we're looking for the third number. So
Hold on, wait. So 25 was the whole number, right?
yeah, 25 is the number of things that are in this set. So there's 25 items.
And then what is 10?
10 is the 10th percentile.
Okay. And then 100 is because
it's a percent.
All right.
Yeah. Really, you could just say that you know that this is a percent. So 10% in decimal form or in fraction form is 10 over 100. But this is how we defined it. So this is how we're going through it. So there are 2 numbers below the 10th percentile number. So the third number, 17, is the value of the 10th percentile. Okay. So value is 17. Well, how about what is the value of the 40th percentile? What do we write down there? V equals what? What does
25.
25, yep.
Times 40 over 100.
That's exactly right. All right. So 40 over 100 is
40.0.4.
Yeah, it's 0.4. Or if we don't go into decimals, it's 4 over 10. What is 25 times 4?
100.
100. What's 100 divided by 10?
The answer's 10.
Yeah. So 100 over 10 equals 10. So there are 10 values below this 40th percentile. So what is the, let me share my screen back.
I got a question.
Yes.
Okay, so like when you doing like the fraction, you gotta break it down, like simplify it, right? You gotta simplify it.
If you're doing it by hand, then that's what we're doing, is we're simplifying. Yeah.
All right.
You could plug it into a calculator, but if I think it's not difficult to do in your head or, you know, kind of on paper, I will usually go ahead and do it, just because seeing these things done over and over and over is how you get good at it. So the more you see it, the more comfortable you are with it. So I just do it. Yeah, but you could just plug it into a calculator and go from there.
All right.
Yeah. So good question. All right. So there are 10 values below the number that we are looking for. So what is the 11th value?
You mean like the 11th highest number or something?
Yeah, what's the 11th number on that list?
20.
20. Exactly right. Very good. All right. Very nice. So what about the 85th percentile? And this is one that's not really easy to do in your head.
All right, so you do B equals 85. No, I'm tripping. Equals 25 times 85 over 100.
Yep. And then when you plug this in the calculator and do everything, spit it all out, what do you get?
I only got one calculator. Oh.
So since we are going to end up rounding anyways, it's actually, we could actually kind of do it in our head. So because of the fraction rules, you can actually switch the places of these and say 85 times 25 over 100. What does 25 over 100 simplify to?
4.
Close.
You
100 over 25 is 4. But what's 25 over 100? You got them upside down.
0.25.
0.25 or 1/4. So what's 1/4 of 80? Or how many times, I guess what's 1/4 of 80?
80?
Of 80. What's 1/4 of 8?
Not 20, is it? It's
Yeah,
20.
so 1/4 of 80 is 20. And how many times does 4 go into 5 evenly?
Once.
Once. So it goes into 80 20 times. It goes into 5 one time. So this means that there are going to be 21 numbers below the thing that we want. It's actually, if you put it in a calculator, you'd get 21.25. But because we're rounding it down, it becomes 21. So let's share.
I got a question.
Yes.
I'm still confused on like how you get like the last number. Like, like on the first problem, how you got 17.
Okay.
Like,
so
I don't understand it.
You do this equation. It's a good question. You do the equation, and you get a number out at the end, 2.5.
Yeah.
Whatever that number is, you have to round it down to the nearest whole number. Well,
So you round it down to 2.
Yeah, this rounds down to 2. 10 is already a whole number, so you don't have to round it. This is 21.25, so it rounds down to 21. So what you do is you take this number, and that's how many below the number you're looking for there are. I don't like that definition. It's more mathematically correct, but I would prefer to round it up
instead of down,
because that's the number you're looking for. So if you say 2 below this number, you're actually looking for the third largest number. If there's 10 below it, you're looking for the 11th number. If there's 21 below it, you're looking for the 22nd number. So when you go back to your data set,
so
the first one was the third number, 17.
Yeah. Okay.
And then it was the 11th number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11th number. And then last is the 21st number. Well, 5, 10, 15, 20, 21. I'm sorry, it's not the 21st number, it's the 22nd number. So the 22nd number is 31.
Oh, all right. So all you do is just like go up a number from the original answer. All right,
Yeah,
I got it.
exactly.
All right, I got it.
It's don't fault yourself. It is a weird way to say it. I think the other way makes more sense, but mathematically, it's not always correct. Whereas this other way is. So that's why we use it, because it's always correct. So this one is 31. All right, so good questions then. So let's look. And now let's do the other side of things. So we are going to ask what percentile is the number that we are given. So the equation for percentile is the opposite of the other equation. So we're not looking for B, we are looking for P. And that equation again looks like this. P equals 100 over N times B. All right, so score of 23. P equals okay. So what is the value of N?
The value of N? 25.
Yeah. Yep. So there are 25. And we're saying what a score of 23 is what percentile. So what value or what number is 23 in the equation? Or I'm sorry, not in the equation, in the table. So 23 is the what number?
14.
14, yeah. So this is where the correctness mathematically comes in. What we actually have to plug in for B is how many numbers below the number we're talking about there are. So if 23 is the 14th number, how many are below it?
$11.
No. What if it's the 14th place? How many people finished in front of him?
2.
I think you're thinking about it too hard. If you come in 14th, or if you came in 3rd place, how many people were in front of you? There's the 1st place guy and the 2nd place guy.
Yeah.
If you came in 10th place, how many people were in front of you? There's the 1st, the 2nd, the 3rd, the 4th, the 5th, the 6th, 7th, 8th, and the 9th. Because then you were 10th. So there's always one less than whatever you are. So if you were 14th, then the number we plug in is 13. Okay? So, because this is 23 is the 14th, B in this case is how many numbers are below that number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we plug in 13. And when you do this, again, this is actually pretty, given the data set, it's actually pretty straightforward. What is 100 over 25?
4.
4, yeah. So then what is 4 times 13?
52.
52. Very good. So this is in the 52nd percentile, because 52% of the answers, or of the scores, are below this number. All right, so let's do the same thing for the next one. So how many total items?
25.
And a score of 35 is at what percentile? How many scores are below 35?
24.
What?
24.
24, yeah, because it's the last one of 25, so all of the other ones are below. So what is 100 over 25?
4.
And what is 4 times 24?
16. 96.
96.
Oh yeah, 96. Yeah.
Very good. So the 96th percentile is the highest one. And this is why, like on SAT or all of your standardized testing that you ever did when you were a kid, the highest possible grade you could make was what?
Oh no.
Even if you got every answer correct.
Was it 80, right? 80?
No. If you got every, oh, I'm sorry. I should have been sharing this. 100 over 25 times 24 goes to 4 times 24 equals
96.
Yeah. So, sorry, I thought I was sharing that. My bad. But if you got the best score, like you got everything right, you were number 1 across everybody, you could never get a 100 percentile. And it's because of this idea. The highest one possible on this is 96th percentile. But if there were thousands and thousands of this, then even if you got the highest score, you can't be above 100% of the scores because you are one of the scores. So you could be above 99% of them, and it could even be 99.9%. But you can never be above all of the scores because you are one of those scores. So on these kinds of grading things, you can't be above you can't get 100 ever, because the highest possible thing is 99. For the same reason that the quartiles, there was only 3 of them, Q1, Q2, and Q3. For percentiles, there's only 99 of them. So let's do this this last one. And thank you very much for the interaction in class. Those of y'all who are speaking up, I definitely like to see it. So let's do this last one. A score of 19 is at which percentile? So, what is our N, first off?
25.
25, very good. And then how many numbers are below 19?
Would be 7.
So let's see. 1, 2, 3, 4, 5, 6, 7. So this is.
I counted the other 19.
So this is kind of a. It's not. I'm not going to call it a trick question, but it's a tricky question, because which 19? Are we talking about the middle one? Are we talking about the top one, the bottom one? And the rule is these are all in the same place. So they are spread out, but it's like if you've ever seen ties, let's say you had somebody come in first and second, and then 2 people tied for third, and then somebody came in that next place. The way that they would list them is, let's see, you have first place, second place, and then you have one person in third and another person in third. But then what place is the next guy in?
Fourth.
Still on 3rd.
They wouldn't be in fourth.
They're still on 3rd, right?
So there's 5 people in a race. First place, second place, 2 guys tie for third place. What is the other guy in?
Fifth place.
He's in 5th. Because how many people were in front of him?
Oh, yeah.
4. And this is the weird kind of thing about counting things this way that you could have ties, is it's all about how many things are in front of that guy. So there were 4 in front of him, so he's in 5th. There were 2 people in front of both of them because they came in at the same time, so they're both in 3rd. So the way we count is we count to the first 19. So 1, 2, 3, 4, 5, 6. Because the first 19 is the 7th place. So B is actually 6 in this case. So with that in mind, times 6. What's 100 over 25?
4.
4. And what is 4 times 6?
24.
What?
24.
24. Very good. Yeah. So this is, it seems pretty straightforward, but it is a little weird when it comes to figuring out what to put in for B. N is pretty simple and straightforward. P is pretty simple and straightforward. But B can be a little weird because of the way we have to count it. Just remember, B means below. It's how many numbers are below the number you're looking for. So in the first one, there were 13 numbers below the number that we were looking for. And then there were 24 numbers below that, the one we were looking for. There were 6 numbers below that one. So just remember, B stands for below. And this is why on that previous slide, I said that it's a little weird to think about, why do we talk about the number of values below? Why do we round it down instead of just going up to the next one? Well, it's because of going this way. Going this way, it makes perfect sense to ask about B as in below. But the other way, there's this weird rounding stuff going on, and we're not exactly sure how to deal with that.
Hey, I like on the homework. I don't see this on the homework. Like they got like range and mean instead of having this for the next homework assignment.
So this is 10 point.
Have we did range it?
Yeah.
This is 10.3.
10.3. All right.
Yeah, so this is all kind of in 10.3. In the 10.3 homework, they talk about quartiles, not percentiles. But it's the same idea. It's just quartiles are a little bit easier because there's not as much math. You can do it visually. But if you wanted to do it math-wise, it's the same idea. But how many how do I put it? What's the largest value of a how do I want to phrase it? The quartiles are only done with 3 different percents. You can either do it for 25%, 50, or 75. So it would be the exact same thing, but only with 25, 50, and 75.
When is our next test for this right here? All this stuff coming right now.
Let's see. It's gonna be, where's my calendar? So finals week is, I think, that first full week in May, May 4th. So our test will probably